All right, guys, let's start talking about logarithms. Logarithms are a very new concept, so I guess buckle up and put on your best thinking hat. Uh, let's talk about the motivation for why we have them, and then we'll introduce some definitions and eventually get to some manipulation using them. So obviously, you guys know that 2 to the second power is 4. You also know that 2 to the third power is 8. However, if I were to ask you a question like 2 to what power is 6, this is a math question that you guys, let's not do that. That is a math question that you guys would get stumped on, okay? If I asked you what number does this work for, you guys should be able to come up with a very good guess. It would be somewhere between 2 and 3, right? Because 2 to the second power is 4, 2 to the third power is 8, so 2 to the 2 point something would be 6. However, that's not going to be good enough. And so we have invented a process for getting variables out of your exponent. Okay? That's the whole motivating factor for logarithms. I'll say it again. We want to be able to find a way to get variables out of our exponents. We haven't done any of that. We haven't solved equations with x in our exponents yet. And so the way that we're going to do that is to get our variables out of our exponents is to introduce something called a logarithm. So let's take a look. Definition of a logarithm. The logarithm of y with base b is denoted by this. Okay? Log base b of y is x. That's how you would say this statement. So there's going to be the word log, a little base b, and then y equals x. And we have a definition for it. You guys, up until this point, are very used to seeing statements in the first form in exponential form. Right? We are used to seeing this. B to the x is equal to y. That statement is the exact same as this statement, just in a different form. Log base b of y is equal to x. That's how you would say that. We know how to say this statement here. B to the x power is y. This statement here is going to be said, vocalized as log base b of y is equal to x. So you would read this as log base b of y, like I said. That's how you would read this statement. And one of the things that I want you to note is when I said this, log base b, whatever the base is of your log is going to be the same as the base in exponential form. Some of the first questions you're doing is essentially just converting it from one form into the other form. And so that task is pretty easy, or at least made easier if you can imagine, okay, whatever the base of my log is also going to be the base of the exponent. Moving on. Let's try an example here. We know that 5 to the second is 25. You guys know that to be true. That is in exponential form right now. We need to be able to convert it into logarithmic form. So whatever the base is, the base of this exponent is 5. That's going to be the base of my log. So I would rewrite it as log base 5. Okay, so whatever is on the other side of the equal sign is going to be the thing that's full size next to log. So 25 is on the other side of the equal sign. We're going to have log base 5 of 25 is equal to 2. This is a true statement. Okay, log base 5 of 25 is equal to 2. I don't expect you guys to see that yet, but one thing that I do want you to note is we should be able to convert this back into this form using the same conversion. But one thing that I want you to try to think of this as is this is asking 5 to this power should be the full size number. 5 to the second power is 25. That's true. We can do that again, even if it's a little bit more complicated. 1/5 to the negative fourth power is 625. You could verify that with a calculator. We should also be able to convert this into log form. Let's try a different color. The base of your log is going to, or the base of the exponent is going to be the same as the base of the log. So log base 1/5. The thing on the other side of the equal sign is going to be your full size number. So 625 is equal to -4. I know there's going to be like a strong desire to, you guys have seen this log button on your calculator. It's kind of one of the main buttons, right? So it's not even a second. And you guys are going to have this desire to try to type stuff in using the log button. And I want to tell you, hold up on that. The log button is going to be something that we're using, but you can't do that log base 1/5 using that main log button. So we're going to get to how you use your calculator. We're just not there yet. We should also be able to convert these from log form into exponential form. It's going to happen much the same way. We could think of it as step by step, but if you remember when I had that 5, 2, and 25 example, what log base 3 of 81 means, or equals 4 even, means is that the base to the power of the opposite thing is 81. And that's exactly how this conversion would look. 3 to the 4th power is 81. We can verify that actually worked. So log base 3 of 81 equals 4. That's how this one is written in log form. We can reorganize that into this one here. The base of your log is the base of your exponent. 14 to the 0 equals 1. That's a true statement because anything to the 0th is 1. So when it just comes to the conversion, that's the conversion. That's all you're doing for that part. We should also be able to use this to evaluate some logs. If I had this question here, log base 4 of 64, and I don't have the equals part. So if I'm kind of struggling with this, I could put equals maybe a variable there and solve for it, right? But what I really want to encourage you guys to be, getting to is this is saying 4 to a power, right? 4 to a power is 64. And we could now kind of do a guess and check. We should have a pretty good idea of this, but you could guess and check. Some of these you probably will need to. 4 to what power is 64? That would, of course, be 3. We could do the same thing with this example. Log base 4 of 1/16. That's asking 4 to what power is 1/16? Now, remember how positive and negative exponents work? If you ever have a negative exponent, what that does is it goes down to the denominator, right? So if you can keep that in mind, that's really going to help you here. You're probably going to want to have your calculator to be checking these, but hopefully you understand that 4 to the negative second power would be 1 over 4 to the second, which is exactly what we have here. So this problem, x would be -2. We could continue on like this. We'll do one more. 1/5 to what power is 125? Well, much the same way that a negative exponent converted this whole number into a fraction, taking a negative exponent is also going to flip this. So hopefully that would lend you guys to seeing that this is -3, because 1/5, when you take it to a negative exponent, that's going to cause it to flip to 5 over 1. So 5 to what power is 125? 3, and the negative causes that flip. All right, now let's talk about the log button on your calculator. Like I said, just going and pushing the log button isn't going to do what you think it's doing. It's not doing any of the problems. Those problems would not have helped to be pushing that log button. There are two very commonly used logs in mathematics. Okay, we are most commonly going to use either base 10 or, in this example here, base e. Okay, if we ever do not put a number down there, I want you to know that that is the common log. You assume it's 10. Okay, we call it the common log, but anytime you're working with base 10, you'll never see the book or anything write log base 10 of x. If it's ever 10, they're just not going to write any base, and you need to know that that's base 10. That's what your calculator is doing when you push the plain log button. Okay? It's automatically using base 10, the common log. The other really commonly used log is the natural log, and the natural log is going to be base e. So you'll never see log base e of x. That's like nails on a chalkboard. Instead, they're going to write ln, which you need to know is log base e, called the natural log. So you're going to see that button right underneath the log button on your calculator. So just to reiterate this, if you look at your calculator and you look at the log button, that's base 10. And if you look at the ln button, that is the natural log, which is log base e. So this question here, log of 8, that's the common log of 8. You should just be able to push log 8, enter, and you're going to get some decimal. You're going to get, really, it's an approximately equal to 0.903. Pretty straightforward. Now let's just kind of talk about what log is doing, right? We kind of know the conversion. I'm telling you that if it doesn't have a number, it's base 10. So you guys should be able to convert this into exponential form at this point. This would say 10 to the 0.903. 10 to the power of 0.903 is 8. And you could verify that with your calculator. I'm going to do that right now. 10 to the 0.903, and I push enter, it says 7.998. Okay, so that's exactly the calculation that the calculator is doing. It's saying, okay, log with no button is base 10. 10 to what power is 8? We could do the same thing with this ln of 0.3. I'm going to go ahead and type that into my calculator, and I get negative 1.204. I also just want to tell you right now that typically with logs, we use 3 decimal places. Because they're involved with the exponents, you're going to want to be really accurate. So do not give me 1 or 2 decimal places. You give me at least 3. I'm always going to use 3. That is kind of traditionally the numbers that we round these to in math courses. So let's just kind of verify our understanding of this. Once again, using the conversion, this is in log form right now. We could easily convert this into exponential form. Remember, ln is log base e. So what this is saying is e to the power of negative 1.204 is 0.3. That's the conversion. And I could verify this by typing e to the power of negative 1.204. Remember, e is Euler's number. It's a button on your calculator. Just very much like pi. It's an irrational number. When I type that in, once again, remember I'm rounding. So my calculator gave me 0.2999918. So very accurate, very close, but you are going to have some rounding error there. And so that does give me about 3.3. That's all I'm going to cover for now. In the next video, I'm talking about how to graph statements like this, where we're going to now be graphing logs. In the next 2 sections, we are dealing with more with logs. We are condensing and expanding them, it's called, and then solving equations that involve logs. So it's very important that you understand this lesson. If you don't, please check into my office hours and we will discuss it.